So in this case, we are going to consider a typical exam revision, still working on our clutches as we had our formulas before. So this part that we are given, it was April 2024 exam that we have. So they give us a typical diagram showing us the flywheel, the clutch disc, the pressure plate. Then the information that we are given here, it was actually direct and straightforward. So we're not going to waste our time, guys. Let us quickly take our information as we are given. This is a conical clutch that we are given. So we are dealing with a cone clutch that we have. All right. And on the information, whatever that you're going to read throughout here, later on, they are saying in that information of a cone clutch, assuming uniform wear theory. Remember, guys, I talked about this. As long you are dealing with a cone clutch, as long you are dealing with a plate clutch, go back to the uniform wear theory, uniform pressure theory. They follow those two theories. All right. So, anyways, we are going to look that into consideration. But as we are given here, that this cone clutch that we are having, it follows the uniform. That is the uniform wear theory. So, in your calculations, you are supposed to consider this. You're supposed to put this into consideration. Remember, when you are dealing or when you are working with the uniform wear theory, what exactly are you working with? You are working with the old or worn clutches. So remember those formulas that I listed before. And it is good enough that when we worked with the cone clutches in our previous class, I mentioned what is important for you, the the new clutch, the formulas, and also for the old clutch, working with the wear theory. So, meaning to say, in our calculations, we already listed these formulas specifically, mentioning each and every type that you are given. So, we do not have a problem when it comes to this part because the information, guys, we have. So, let us just take our information and see what we are given. So, we are given that it transmits 240 Newton meter. So what is it that we are given? Newton meter. This is the torque that we are given. So it transmits a torque of 240 Newton meter. Then the clutch surface width is 70 millimeters. This is the width of the clutch. So the width of the clutch, if we are to divide by 1,000, this is millimeters. It was going to be 0.07 in meters. Then it has an included cone angle of 26 degrees. Take note, included angle. So I told you guys from the included angle, you obtain your beta there, the included angle in degrees over 2. That is going to give us our beta. So we have to divide 26 divided by 2 in order for us to obtain beta. Remember, beta, it's a semi-angle, a half angle. So it's half of the included angle. So unless if they specify direct that it's a half angle, but they say it included, so you divide that one by 2. The outside diameter of the clutch is 350. So we know that from this outside diameter, guys, we're going to obtain the outside radius. So 350 divide by 2, you have 175 millimeters there. Then 2 meters divide by 1,000. All right. So you have to divide by 1,002 meters. So that was going to give us 0.175 in meters. And we are also given the coefficient of friction, which is 0.25. All right, assuming wear theory as we are given there. So the coefficient of friction is also given as 0.25. Remember, we are told it's a cone, which follows what? The uniform wear theory. So from this consideration, we have now the question which is, or which was to calculate 1.1, the inner radius of the clutch. So when we had our introduction, even on those examples, guys, we had a typical question like this, where the inner radius had to be calculated. We have the width of the clutch here, remember? We have got the width of the clutch. We also have our outer radius, and also we have got our beta, our included angle. So we know that these can give us the missing radius that we are to find. All right, so that is 1.1. We need to determine the inner radius. Remember, I explained from this triangle concept that we can use it to determine anything that is missing, provided that we are given any three from the formula. All right, so there we are going to use this triangle, guys. All right, so that is the one that you're going to draw. Then from that, you substitute your values. So remember, we say the sine of beta from there is equal to the opposite over the hypotenuse, which is this formula that we have here. So I'm not gonna redraw that triangle, guys. All right, so this is the formula that we have, or that we had at the end. Remember, guys, we had a question like this actually on examples. So it's just a repetition, this one. What we need is this internal or the inner radius. So let us make it the subject. So this is same as over 1. We can even cross multiply here. So that's W times the sine of beta. So these two, they cross multiply. So it's going to be W sine of beta, which is equal to 1. Is going to multiply this part. So that's R minus R that we have. So remember, I want to make this the subject. It is carrying a negative where it is. So let us take this side so that it can be a positive. So taking minus R to the right, left side is going to be positive. All right, meaning to say we are left with this one on the right side. All right, what about this part? We have to take it to the other side. We do not need it. Remember, we want to make this the subject. So the moment it crosses the equal sign there, it becomes a negative. So it was going to be negative W, the sine of beta, like this. So this is the formula, guys, that we have manipulated to make R the subject, where we can simply substitute these values as we have them. So meaning to say, therefore, our inner radius was going to be what? Since these values are in meters, it follows that our answer is going to be also in what? In meters. So that's 0, 175 minus our width of 0, 0.07, the sine of beta, which is 13 degrees. So this is it. We were going to have our inner radius. So that's 0, 0.175 minus 0, 0.07, the sine of 13 degrees, like this. So that's 0, 0.159. All right, we can even fix this. Let's fix, guys, straight to 3 decimal place. All right, 0, 0.159. So that's it, 0, 0.159. Like I said, it is in meters. Since this one is in meters, this one is in meters. So whatever that we have there after subtracting is in meters also. So that's it. This is our inner radius. So we're going to take it, right, and just save it on our information. So we just calculated our inner radius, and that was 0, 0.159 in meters. You can even convert it to millimeters because you're not told you have your answer in meters or what. But for the sake of other calculations, we know that we'll be dealing with what? Meters. So it is best for us to have it in meters like that. They said radius, not diameter, guys. This is inner radius. Find the radius, you end there. All right. Do not multiply that one by 2. Multiplying by 2, you're now determining or finding what? The diameter, which is not part of our question. All right. Then I talked about this. Maybe some of us did not understood me. I remember now. Let me talk about it. If we remember when we talked about the talk, it's something else. It's no longer about this question that we just did. It's fine. We are done with this one. Remember, I talked about the error that is on our textbook. Is that was the TVET series. Yeah, it's supposed to be TVET series, which made a mistake. It was actually a mistake. So that one, it continued throughout. That's why I have to focus with this one because it was not on one page, but almost everywhere when they write about the talk that is transmitted. All right, it is here. Sorry. I talked about it here so that we can be together here. Remember when I talked about this formula, especially for those on membership, you can understand much because that's where I focused on that question here, where this is the formula that we are supposed to use to calculate the torque as long as we're dealing with what old or worn clutches. That is where theory. Okay, I talked about this. The mistake was using a 4, right? On their formula, they used a 4. So if you check, they used a 4 throughout. So I want us to confirm that because I talked about this, that if we are to say we bring this information, all right, let me take my formula. I'm saying the torque is given as coefficient of friction times FA like this, everything over 2 sine of beta like this. Let's say you have this FA, this one. Let's say you calculated, you are given the axial force. In this case, we do not have that one. But let's say you have that axial force and you substitute it back. You are going to see that you have exactly the torque that you're given. But if you use the one that is a 4, you won't get those answers. So I want you to just work out those as an individual. As an individual, just try to see how these are going to work out. Remember, when you're dealing with the axial force, it depends with the condition that you are given from the pressure that you're also working with. So we are not supposed to confuse that question. All right. Anyways, we're just gonna talk about it. I just remembered it when I was seeing this question here. So, anyways, the axial force required to engage the clutch. All right. So to engage, remember we talked about these formulas to engage the axial force. To engage, which we can write as FE, depending with your textbook that you are using or the source that you are having. But it is equivalent to FA into 1 plus coefficient of friction over the tan of beta. All right. So we listed these formulas previously. So it is not a problem here. We're just going to substitute. But we do not have this axial force. All right. In our case, we do not have the coefficient of friction. We have it. The beta is there. So what is going to be the case to calculate that axial force? So we are told on our condition that what we are dealing with is an old or a worn clutch. So how are we going to calculate our axial force? Remember from our previous consideration, I said the axial force, sometimes you do not have to calculate it direct. All right, we have to understand each other here. The axial force is the product when you are given, let's say we have the normal force. It is the product of the normal force, the sine of what? The sine of beta. All right, for the sake of understanding each other, we have it here. All right, so if you still remember here, old clutches, we talked about this. So that's normal force times the sine of beta. We had this part. But if you are to check again, we do not have that normal force. But we said the normal force can be found from this where we do not have that axial force. That's why we ended up with this formula. So meaning to say the formula now that is to give us that normal force is the torque. So if this formula is wrong now, or if you are using the wrong formula, guys, it means we are now having wrong values at the end of the day, because we can see that from this formula, everything is there. The axial force is there. So if you used or if you took a wrong formula now, guys, everything was going to be affected. So I want you to see with this formula, that is direct, or from here. That is anything we can have it from there. It is up to you the way that you are going to have it. All right, so let me explain from the first one. All right, so let me do this, guys. I just hope you understand me here. So we said from that torque formula, the torque is given. All right, we took that one coefficient of friction, that is Fa over 2 sine of beta. So this is 2 sine of beta into R plus R like that. So I explained where this part is coming from. This part over these two is our effective radius. Remember, that is R plus R over 2. So that is why it's supposed to be like that. So we have that FA here, guys. We can see it. We can simply make it the subject. If we're going to cross multiply, it was going to be 2 sine of beta times the torque that we are having over what? We're going to divide by the coefficient of friction into R plus R like this. So that was going to definitely give us this axial force, the one that we need here. So let us substitute our values and see. So the axial force is equal to 2 sine of beta. Remember, our beta is 13 degrees. Then our torque here is 240. That's 240. So I'm going to explain another formula also. That's why I was like, let me find ways that I can explain this, guys, so that you can understand me. But there's so many formulas, so many formulas. All right, the coefficient of friction, 0.25. All right, let's hope this one is not going to affect us. 0.25. This one is a product, but this is a sum. So we're going to add. Remember, we just calculated. This is our outer 0.175. This is the inner. We calculated these two. All right. So we calculated the outer and the inner. I mean, the outer was given, which is the outer radius. That was 0.175. And the inner radius we calculated, we got 0.159 like this. All right, so let us use our calculator and see what are we going to have there as our axial force. So that's 2 sine of 13 degrees. You close that bracket, then times 240. All right, so everything is over 0.25 times. All right, let's just open a bracket there and add these to 0.175 plus 0.159. All right, so this is what we're going to have as our axial force, which is 1,293,132 in what? In Newton. So you saw the formula, guys, that I used there. The formula that I used is having a 2 here. So for us to be actually very sure about this formula, let's take this into consideration to say the axial force could have been calculated from this. So we are supposed to have the same answers there. We are supposed to have the same answers. But remember, I said, no matter the way that you understand, or no matter the way that you're going to take these calculations, there is one part that is not going to change on our talk. This one. This is the basic formula on how you calculate your talk. This one. And this one, guys, the guys does not even change. If the interpretation is the one that changes on the formula there. The interpretation. So meaning to say with that, guys, we will never get wrong. This is the same formula that we ended up here when we made the subject of formula. If you still remember, when we listed this, when I talked about this formula here, when we made our Fn, the normal force, the subject, because we said in this case, when you're dealing with a cone clutch, our N is equal to 1. So there's no need for us to even use that N, but we're supposed to make the subject and have it like this with an N being 1. But there's no need for us to have that because N is equal to what? N is equal to 1. So meaning to say, this was the formula that we're going to have at the end. If we manipulate from that torque formula, it was from that torque, guys. Torque is equal to the product of these. That was our formula. Then we simply made the normal force the subject. All right. So on this one, I hope we are together. So the normal force was supposed to be calculated from this torque over what? Coefficient of friction times our effective radius times N, where N is 1. So we ended up not considering that for a cone clutch, it is not even necessary to consider this. So we will see that this we have, we do not have what? Our RE. Remember, we are dealing with what? Worn or old clutches. Our effective radius is equivalent to what? Our RE is the same as the mean radius, which is simply our R plus R over 2. So you are going to calculate that one, all right? So let's say you calculated, what to see, guys? 0.175 plus the R that we calculated here, 0.159 over 2. All right, so you're going to calculate this, and you're going to get something like 0.167 in meters. That's our effective radius for old clutches or for worn clutches using the uniform wear theory. You have it, your effective radius. Let us put back into this calculation and find our normal force. So from this, our normal force is the torque which we're given of 240. The coefficient of friction, remember that one, guys, we're given 0.25 times the effective radius, which we just calculated now, which is 0.167. All right. So you're going to substitute this one, 0.167. All right. Then you have got your normal force. So your normal force was going to be something like 5,748,503. So let me just take it like this so that we do not round off a lot of values. So with this normal force, you are then going to calculate your axial force from that product. All right. Remember, we're dealing with a cone. So at the end of the day, we said our axial force is the product of this, the normal force times sine of beta. All right. So we're going to take our normal force, 5,748,503 times the sine of beta, where our beta is what? Where our beta is 13 degrees. So our axial force at the end of the day, if we were to multiply this, it was going to give us 1,293.132 in Newton. So as you can see, we are having same answers with this from this formula that we said it was written wrong. So you can see that the textbook actually, guys, gave us a wrong formula, because if you are going to use a 4 here, let's say you put a 4, if we're going to put a 4, you're going to see that the answers, they were definitely going to be different on your calculations if you were going to put a 4 there. And definitely that means everything was going to be wrong. If you put a 4 here from that formula, you will see that this answer was not going to correspond with this one that we calculated this side. But as you can see, with this formula having these two and this part, we are having same answers as if we are calculating something else. So this is to show you that mistake. So I just hope on that part, guys, we are together now. We're not going to have challenges, but if you still have challenges on that to understand, guys, let me know. The comment section is there. Let us communicate so that we can see how to explain, because I talked about this, that our revised curriculum textbooks, they were done in a hurry to service all of you guys at the same time in a short period of time. So those revisit, checking out the textbooks, never done properly. So anyways, that is it. So the question was to calculate the force to engage, not the axial force. All right. So with that axial force, we now use it to calculate the axial force to engage the clutch, to engage. So the force to engage is going to be what? Our axial force that we calculated, which is this one. All right. So you're going to put this value as it is here. So that was 1,293.132. All right. So into what? So you're going to substitute, as you can see, this part is as it is from the given information. So that's 1 plus the coefficient of friction of 0.25 over the tan of beta, where our beta is the angle of 13 degrees. So this part is clear, guys. It is now you and your calculator. So that was going to give us the force to engage of 2,693,425 in what? In Newton. So that's it. You can even convert to the kilonewton. It's going to be 2.693 kilonewton if you want to have it that way. So as we can see, guys, either way, you can have same answers. So it is up to you. You're going to pick or to take the axial force from the torque straight, where that torque is given straight from the formula, because the axial force is there here. All right. Or you go through the calculation of the normal force on its own. All right. You go through this part. You calculate your normal force separately. Then from there, you calculate your axial force, because you know it's the product of normal force and the sine of beta. Remember, it is the axial force and the spring force, which are exactly the same. So once we calculated the axial force, we also calculated the spring force. I talked about that. So that is it. It is up to you guys how you pick or how you answer these questions. Let us move on to another question. All right. So that was it. The first to engage. To engage the clutch. So definitely they will ask about something to disengage or to hold that engagement. Let's see if it is the case. But in most cases, that's how they ask these questions. All right, you see, that is it exactly. So 1.3, the smallest force required to maintain, that is to hold engagement. Smallest force required to maintain, it is the force to hold that they are simply asking. So that's our FH. Remember, the difference is just that we are going to have a negative on our formula. That's the only part on to hold. And that is the only part is going to be having a negative. So meaning to say, guys, from this consideration that we are having, you were going to put a negative. All right. You're going to put a negative from your formula. Then we can make our calculations. As we can see, everything is already there. We calculated everything. The axial force, which is this one, 1,293.132 into 1 minus the coefficient of friction, 0.25 as it is. All right, over the tan of beta. All right, then there are others, I don't know, who are not comfortable with the point or the comma. All right, guys, I don't know the way that you understand. If you take a point as a point, if you take a comma as a comma, that one is in your hands. We do not have this one the way that it sounds the same. I actually talked about this before to say the way you call it, guys, call it the way that you call it. As long you understand what I'm writing here, that is the most important thing. Because those ones, if you go to another country, they call it another thing. If you go to another country, go to another, it's differently specified. So it is you guys, it is you who call it the way that you call it. All right. But as long you see what I'm writing here, it is fine. Because some of the comments, guys, that we get, you see, like this one does not even know what to say. Or you see some of the things, guys, of all the things that you have learned, like that you have learned as an individual, you find that one as a comment that you just put. Of all the things, like guys, some of the other things, we need to be also be reasonable as individuals that are preparing for exams, so that even us, as we are working with this, we know exactly what is that you need. I just hope I did not sound bad. All right. So the negative there, I talked about this, guys, is for the disengagement. But for N6, guys, we are not supposed to talk about these things. For N6 people, I think that we are talking about people are already mature enough to know what they want in terms of this education. Anyways, so this is it. 1.3, you've got your negative. It's a sign of disengagement, that one. If you see it, but does not even matter. You write that part or you do not write it. The answer, guys, is just write your answer as it is. This is the force that is to hold that engagement. All right. So, guys, as you can see, these questions, they are direct and straightforward. After those formulas that we listed and examples, now it is just like a play. It is supposed to be like that, especially when you are preparing for exams, guys. Do revise these questions this way. All right, 1.4, the maximum pressure on the plates. Why are they saying the maximum pressure there? Why is it about the maximum pressure? Remember, when we are dealing with the old worn clutches, you don't just talk about pressure to say this is pressure. No, the pressure has to be specifically mentioned to say which one are we talking about, because the axial force as it was calculated, remember, okay, these are the formulas first to all this one. Remember, I talked about these ones here for all the clutches. The axial force, when it is to be calculated separately, if we take that one and say, okay, this is our axial force, it was supposed to be calculated from any of these formulas. So if they specifically mention that it is the maximum, so where the maximum pressure is, we know that we'll be dealing with the inner radius in our calculations. So it is from the axial force. Now, for all the clutches, guys, it must be specifically mentioned. That one we have to be honest. All right. So meaning to say from the axial force, we saw that where we have got the maximum, it is from this formula, 2 pi r into r minus r like this times p max. So take note, there is the inner one that you're working with. So that's our maximum pressure, this. So let us simply make it the subject of the formula. We're simply going to divide by this whole part here as it is. So that's our maximum pressure was going to be the axial force over 2 pi r into r minus, like this. Okay, so that's it. Going to substitute our values straightforward. So our maximum pressure is going to be equivalent to what? The axial force is already, we calculated this separately. Remember, that was the one that we got of 1,293,132. Everything over 2 pi times the inner radius. All right, so the inner 0.159. So this is 0.159. All right, so that's the difference here, outer minus the inner again. So the outer 0.175. Then we're gonna subtract the inner one. The inner is this one. So that's 0.159 like this. All right, so that was gonna give us the maximum pressure with this formula that we have. So if we are to simplify properly, that was going to be 80,000 and 899.509 in Pascal. Remember, this is pressure measured in Pascal, which we can even convert to the kilopascal, divide by 1,000. It was going to be 80, comma, this is going to change into a 10, and this one into a 9. So that's it, into what? Into kilo Pascal. So that is how we are supposed to have these questions. So as we are making our revisions, or as we are having our revisions, guys, let us put into considerations questions that are having or that are still giving us challenges. Then we talk about that on the comment section. But the way that we present those questions, let us also be in a manner that we understand each other. If you have got a question that you want to ask, you're part of membership, you are not part of membership, all of us, we can ask the questions, and that can help us to grow together as we are moving, as we are preparing for the exams that are ahead of time. So that is it, guys, from this part till we meet again.